Good. First of all, thank you everyone for coming over. Really appreciate you taking time. Sometimes I do get a bit lazy and I don't show up for meetups. So thanks a lot indeed. I just tried to make this a bit theoretical and also a bit practical, but I'm just only going to go to a certain extent with regards to explaining concepts, because only certain concepts are absolutely essential for you to operate using Kafka, and the later bits you can just go and read the documentation if you find the topic more interesting. I don't want to go too deep, yeah? If that's fine with you. Oh well, everybody probably here already heard of Kafka. Who doesn't know what Kafka is from a very, very, very high level? Right, okay. Well, Kafka is nothing but like a publisher subscriber system, or yeah, if you're familiar with a JMS queue or something like that, that's a probably good place to start. So that it all started in LinkedIn by this guy called Jacobs, and he was in charge of building the infrastructure within LinkedIn, wherein every activity was sent between their applications or the systems through messages. So that's why they started with this particular project. What they found out back in LinkedIn is that the existing systems couldn't really cope up with the load of data that they were trying to handle at that time. So yeah, well, if you can't buy a product that can actually meet your needs, they thought, well, let's just build one. This is actually the kind of mentality in Twitter and Google as well. Interestingly, met a few folks from Twitter, and they said, you know what, we don't really buy any product, we build over buy. Quite a nice philosophy. Right. So in short, it is. I'm going to go ahead. This is actually the formal definition. So it's a publish subscribe messaging system, and they say that we rethought of it as a distributed commit log. Well, first of all, I'm just going to go and explain all these terms and how they all fit together. But these are what they were trying to achieve. They want a system that's super fast. Yeah, that's the first bit. And they want something that is highly scalable. What was the problem with the current set of products that they had, or the set of products that they had back then, is that they were not really scalable, which means when you had reached the threshold for a number of producers and consumers for a particular queue or topic, and then you try to go beyond that point, the system really struggled. It sort of felt like the single point of failure, because when the messaging infrastructure sort of died or fell down or struggled, your system, your ecosystem of applications or your landscape started to really struggle as well. It started to feel the pain, you know. And then, well, obviously comes durability. They all sort of go together. And yeah, so, well, I'm not going to come over here and tell you that Kafka is the next best thing. It's one silver bullet. So throw away your RabbitMQ infrastructure. If you have anything else from, I don't know, MQ product from IBM or Oracle, throw them all away, and then you put Kafka in. No, that's not the case. Kafka is suitable for certain use cases, so you really have to understand what are the strengths and weaknesses of Kafka, and if that really fits your needs. Yeah, so that's what we're going to try and understand today. Well, it's also a new thing. Just bought it 2 days ago. So, right. So this is the classical publish subscribe messaging system. So yeah, you have a publisher sending out messages to a particular topic, and you have a set of subscribers that have subscribed themselves to a particular topic, and once they are in the subscription list, they do get the message delivered. Yeah, this is the classic definition of publish subscribe messaging system. Any questions here? No? Good. All right. So, well, Kafka is supposed to be distributed in nature. Well, the first thing that anyone would think of when you hear the term distributed is that it runs in a cluster, and Kafka is no exception. It also runs in a cluster. So when I say Kafka runs in a cluster, it means it typically consists of several servers, and each one of these servers are called broker. So if I'm using the term server or broker, I'm just referring to the same thing. Broker is just a Kafka term for a server that belongs to a vertical cluster. So obviously the communication between clients and server takes over TCP, and this is how it looks like. Yeah, so you have a set of producers over here, and then you have a set of consumers over here, and this is a Kafka cluster. You have a server over here. It's a physical server. You can think of it as a physical server. It can also be a logical server. So you have a server 1 or broker 1 over here, and it has a logical topic. Just think of a logical stream of events that you want to title or group. So just you know what? Give me an example. I need two. What would be a good topic 1? Okay, but that's just an event. So I want, how would you categorize all the events that relate to user login? Say user activity events. It could be user logging in, user logging out. Yeah, the user just authenticated, something like that. Yeah. So first one could be something like user activity events. It's really nice that you said that, because that's exactly what we're going to use in the demo. So, so you made my life easier. Thank you. You can have an extra beer. Robert would help you. Right. So we're going to go and take a bit deeper dive into high-level abstractions. So the first one is topic. Well, as we just talked about, a topic is just a logical categorization. Yeah. So a topic can be something like user activities events, and a topic is divided into multiple partitions. Now, let's say we have this logical thing called user activity events, and why would you want to really split them across into, or divide them into partitions? That's because if you consider there's a broker, which is just a server, it's got a limited amount of memory, it's got finite set of resources. So anyone who tells you that, look, we have infinite resources, they're all lying to you. So a server has got finite set of resources, it's got certain processing power, it has got a finite amount of memory. So you don't want your application infrastructure to be designed in such a way that it outgrows the particular server. Well, Oracle will be very happy. Back in 2012, they were trying to sell you Exadata and all these big machines, you know, scaling vertically, so that if you're a bank or a big financial services company having a lot of money, just pay them off to Oracle so that Larry can buy another yacht. But yeah, well, things changed, and that's why we thought, well, if you are running something on a commodity hardware which is not too expensive, and the amount of events that you're trying to process grows, the capacity of your particular hardware, which is CPU and memory, which is what it basically boils down to, then you can just stack up a series of servers or brokers in the sense, and then you can place some partitions across these brokers so that you can easily scale. That's why that's why this topic has been divided into partitions. Well, it's called a commit log because the ideas actually came from the database world. Whenever, if you're familiar with Cassandra or any other, classical relational database, what they used to do is they used to append all your read and write operations into commit log. That's the first place that it gets into, and once it gets into the commit log, that's why the phrase also two-phase commit. I guess most of you are familiar with the phrase two-phase commit and the concept behind it. So it is all, sorry. So the partitions that over here are nothing but they're ordered. So if you're sending messages like 1, 2, 3, they're all saved like this, and they're immutable because once you send a message, yeah, why would you want to even change it? It's a message, it's an event. Like, what's the temperature of the hay on the 21st of April at 7 p.m.? It's a fact, so it's immutable, and it's a sequence of messages. So they try and append it continually. So that's why the term commit log comes into play. And then, well, they're sequential, which means they have sequential ID, and you can refer it say this particular message over here, you can refer to that with an offset 8 for partition 2. That's how the consumers actually refer to the message. So you can just jump directly to that particular message. That's how they uniquely identify. Now, as I just told you, so you have a cluster, a Kafka cluster with 5 brokers, 1, 2, 3, 4, 5. Yeah, and then you define a particular topic, and that topic, which could be our user activities events. So this one is now being divided into 4 partitions. So 0, 1, 2, 3, because Kafka is actually written in scalar. It all comes with a Java, numbering system. It all starts with a 0, not the 1. That's why it also starts with a 0. So you see, this particular topic is being configured to have 4 partitions, so that it can outgrow the capacity of a particular machine. And then you can say, okay, what we're going to do is we're going to say broker 1 will have partition 1, broker 2 partition 2, broker 3 partition 3, broker 4 partition 4. But Kafka is also a durable messaging system, which means what it does is that one of these brokers will be, let's say for example, this particular partition 0 will be stored in broker 1. That will be the leader. Yeah, that will be the broker which will be responsible for all the messages that the producer is sending over to that particular partition. The other ones are followers, and you can define the number of followers with a replication factor. They will get all these messages by listening to the leader. So they passively listen, and it's also used for, what is it called, load balancing. So load balancing and also fault tolerance. So if the leader goes down, you obviously have a follower which has the same sort of events for that particular partition. So you can go and elect that particular follower as leader, and then that takes over. Any questions so far? I have no idea how Mongo works, so I'm off the hook. Sorry.